This is a production of Cornell University.
It's really delightful to be here. I'm very thankful to Alex and to Kathy for helping to bring me to Ithaca, and very much to Lou as well, who is somewhere in the back, for helping on all the logistical arrangements. It's fun and also frightening to talk about these topics in front of a room full of scientists, which is not my typical audience, because you all will know when I'm saying things that are totally wrong. The historians don't. And so I hope you'll be kind in the Q&A if I've totally butchered something. But I think I have an interesting story for you. I hope you'll enjoy it. I have to apologize to anyone who's listening to this on Zoom because the PowerPoint looks pretty nice in person, but will look clunky on the internet. So you have my apologies. Okay, so let me begin with the problem of rotten shoes. So the year is 1942. It is late August, and the Australian and American armed forces are fighting to defend a strategically valuable point at the southeastern tip of Papua New Guinea, known as Milne Bay, which is roughly there, from a Japanese assault. Although the Battle of Milne Bay was a small engagement, it was important for a number of reasons. It was, for instance, the first time in World War II that a Japanese amphibious invasion was defeated. But it was also fought in a hot, humid jungle environment with almost continuous pouring rain. This photo gives you a sense of the landscape and its challenges, and this is a field recording from elsewhere in Papua New Guinea. So what you're hearing is the experience of being in a rain in the jungle there. So Australian forces who had been in the region longer noticed that much of their equipment was malfunctioning. Mine detectors did not detect tank mines, radio sets went dead, soldiers found that they couldn't even see through their gun sights because they were clogged by mysterious forces. Boots and tents fell apart overnight in the hot and wet environment. A guidebook published in 1943 by the Allied forces explained, quote, that New Guinea is a primitive, hard country and a new world to men from overseas. You go there to fight a dangerous enemy, the Japanese, but they are not the only enemy. The country itself will fight you. You must be forever on your guard against this silent enemy, your environment. It is relentless. If you relax, it will get you down. And as evidence of what that meant, this is an ammunition magazine after 1 week of exposure in New Guinea compared with a factory fresh magazine. Although this was not the first time that militaries had fought in a humid environment, the scale and the intensity of the conflict in the tropics caused a previously invisible environment to make itself felt very forcibly on world militaries, technologically, scientifically, and strategically. Molds, in particular, microscopic life forms that most soldiers had never even thought about, were coming out of the woods, very literally, to sabotage the war effort. So today, what I'm going to do is trace the development of the science of deterioration prevention, which we can think about as the effort to understand how environments damage materials and how it made our system of sort of global fast-moving goods possible. I've already told you about the problem of moldy shoes. I'm going to continue by giving you background on my larger book project and sort of giving some context for this undertaking. I'll trace how the field was transformed, or I'll introduce you to the field of industrial mycology and talk about how that was transformed by the fighting in World War II. And finally, I'll end by showing how these technical and scientific advances from earlier decades enabled the growth of rotten capitalism, you'll forgive the pun, but an economic system that is structured on an ambivalent relationship with fungi, both proactively utilizing microfungi to produce products, but also destroying fungi to preserve a series of other products. So for the last few years, I've been working on a history of the development of fungal science, as Alex very kindly explained. And I've been exploring a number of connected disciplines, so taxonomic mycology, medical mycology, plant pathology, industrial mycology, and more. And in the project, I'm particularly interested in thinking about how previously ignored aspects of the environment become knowable by scientists and by regular people, and how that knowledge propels novel forms of utilization of those materials and produces new human relationships. So how do we know that a mushroom is a fungus rather than a plant, which most people throughout history did not think? And how does that change our relationship to that thing? What does it mean for how we interact with it? I'm calling the book Rotten Beauty to kind of index this ambivalent relationship that people have with fungal things. Some of them are lovely, beautiful, etc. Some of them are scary, dangerous, and need to be destroyed. So this research builds on my first book. This is the Shameless Self-Promotion Moment, which comes out in May. And there I provide a history of the laboratory dog over the last 2 centuries. You might be wondering, why is someone who wrote a book about dogs qualified or interested in writing a book about mushrooms? And one answer to that question is my sort of repeated interest in Cornell. I mention this in part because an early section of that first book talks about influential research on canine health and diseases that took place not very far from where we are now at the Baker Institute, which was then known as the Research Laboratory for the Diseases of Dogs. This facility opened in the 1950s, and you can see that Ithaca looked a little bit different back then. And it's one of the many ways that my historical interests have kind of returned me to Cornell. And as a historian, I'm kind of interested in the knowledge that we have about other kinds of organisms. Efforts to make sense of dogs or pigs or parrots or other kinds of living things connect unexpected people across places, across disciplines, across knowledge communities. And in the dog book, I was really interested in what is it like for scientists and other people to study an animal that they identify with. So they see themselves in dogs, they like being with dogs. Many of you probably do as well. The question is a little bit different with a fungus, that many scientists who worked with them don't really like them very much. They're kind of disgusting at times. They're not something that you want to have in your house too much of, perhaps. And so this changed the kinds of historical questions that I was interested in trying to understand. How do we come to deal with and understand alien or invisible or microscopic organisms? And so, as this sketch that I found in a Dutch museum helpfully demonstrates, I began to shift my focus from the dog at the top of the tree to the mushrooms at its bottom. And I think with good reason, because today, if you open newspapers, it's hard to avoid this sense that the world needs fungi to save us from a host of modern problems. There is, I think, an eagerness in the cultural sphere for the non-human power of mushrooms and other fungal things to save us from human-made crises. So in my project, I'm trying to bring together a number of historical threads to explain how we got to this point. How did it make sense that fungi could be a solution to global climate problems and other issues? I'm not, however, the first person to try to do this, and I'm following somewhat in the footsteps of Geoffrey Ainsworth, the British mycologist and historian, who attempted in 3 books published in the 1970s and 80s to try to do something of a broad, sweeping history of mycological science. I think the benefit and the fault of Ainsworth's work is that he separated these topics into sort of their distinct disciplinary areas. But in doing so, I think he accepted the idea that these are different undertakings. And I'm interested in trying to bring some of these things more together and tell a more comprehensive story about the development of this knowledge project. So I'll give you just a few overarching kind of threads, and then I'll get back to the question of rotten stuff. So part of what I'm interested in is tracing the development of general mycology as it emerged out of botany and separated itself from conventional medical knowledge in the late 19th century. I'm looking at tools of visualization, from watercolor and microscopes to DNA sequencing and image recognition algorithms, to show how a vision of mycology or fungal biology as a sort of worldwide project began to take over in the early 20th century. I'll say a bit more about this a little bit later. I'm also interested in tracing how medical mycology gradually separated itself from other ways of knowing and engaging with fungal things, and how the people who study fungal infections became sort of caught at times between different worlds, between medical schools and biological laboratories, and often suffered the funding challenges of both. The historic marginalization of medical mycology, I think, is really important because today we know that fungal diseases are of growing prominence and importance at an international scale. So the World Health Organization has said that the next pandemics could be fungal in origin. Climate change, of course, is increasing this risk. So I think it's important to understand this history and understand why we haven't done so much research in that area. Another area of the book that's, of course, very relevant here is the development of plant pathology. There's a major transformation at the start of the 20th century where suddenly universities all around the world are opening programs in plant pathology, including this one here at Cornell, and begin to see the subject as essential for the development of international agriculture. So how did that happen? Why did that happen? And how did that influence our sort of modern version of agriculture? And those of you who know a lot about rusts will maybe recognize this as part of Elvin Stackman's early research into wheat rust. So those are a few of the threads of the book. I can talk more in the Q&A. I didn't want to bore everyone with too much sort of overview. But what I'm trying to argue is that although often kind of ignored and thought of as a subsidiary or unimportant area, research about fungal things really transformed and shaped the 20th century in very prominent ways. And I think I'm preaching to the choir here, but I think more people need to think about the history of mycological science and understand its importance. All right. So to illustrate a bit of this ambivalent relationship that people have to fungi, I want to talk a little bit about the field of industrial mycology, where it came from, and sort of show how this developed into a much kind of broader and more nebulous sort of study of environmental deterioration. In 1938, British mycologist George Smith published the first edition of the Introduction to Industrial Mycology, and acquainted many people with a new area of knowledge concerning fungi. As Smith explained in his preface to the first edition, quote, "This book is intended to assist those who are commencing the study of molds rather than of fungi in general. There is already an extensive literature of systematic mycology, plant pathology, and medical mycology, but there has been up to the present no book in English dealing particularly with the fungi which are of importance in industry." So as Smith made clear, there was a great amount of mycological knowledge in existence, but biochemical knowledge of molds was urgently needed. So what had changed to make that necessary? Biochemist Harold Raistrick, who is today so little remembered that I actually had to create his Wikipedia page, explained that the two basic challenges of industrial mycology in a foreword to Smith's book. So he said, on the one hand, you have all these industries involved in handling organic materials, including the food industry, the textile industry, wood, et cetera. And all of these industries were losing extensive supplies and products to the destructive powers of fungi. Antifungal sprays and other kinds of things were needed to combat these molds. But then on the other hand, biochemists had recognized the marvelous powers and capacities of fungi for producing useful industrial products. So many of you may know that prior to World War I, most of the world's citric acid came from lemons in Sicily, which are shown here, and they were used in the production of things like sodas, desserts, et cetera. But World War I cut America off from citric acid, so they had to find artificial and synthetic ways to produce citric acid without getting all of these Italian lemons. This was an important development for a whole bunch of reasons. It's really bad for Sicily. But it introduced a lot of researchers like Raistrick to this idea that you could use small fungal organisms and produce these kind of fantastic and useful industrial products. Raistrick knew about all of this firsthand because during the First World War, he had participated in secretive research to use yeast to produce glycerol, which was a key chemical for explosives. His findings were utilized in the war effort, but they were also really valuable for the British mining industry in peacetime. So a lot of synthetic explosives were produced for mining. In subsequent years, Raistrick focused his attention on assaying fungi for a whole bunch of other useful industrial purposes. And in the 1920s, he took up a chair in biochemistry in the London School of Hygiene and Tropical Medicine, where he appointed Smith, the author of the book, as his research assistant. Rather than explosives, though, Smith came to industrial mycology via the clothing industry. He began his career as a chemist for the textile manufacturer Boardman and Barron, which is, the headquarters are very blurry, they're hard to see. Boardman and a number of other companies at this time were producing dhotis, which is a sort of white cotton fabric that was shipped to British India to use for clothing and a bunch of other uses. During the long oceanic transit, however, from England to India, a lot of these things mildewed. They became sort of destroyed by fungal processes that was then known as tendering. This was not a brand new concern at this time period. For instance, this print from the 18th century Japanese artist Katsukawa Shunsho appears to depict women airing out books to prevent mildew and insect infestations. according to curators, which kind of demonstrates that this fight against spoilage was a very long-standing one. But Smith's work showed how the British Empire and this kind of continent-spanning scope made a lot of these economic problems much more serious and requiring action. Although the exact numbers are difficult to come by, it's clear that a huge number of cotton goods were destroyed by mildews during this period. In response, the British Cotton Manufacturers Research Arm in Manchester, known as the Shirley Institute, shown here, invested significant effort into understanding how to prevent and destroy these molds. At the time, the most effective solution was the application of zinc chloride, which protected clothes, but you needed to use a ton of it, so it was really expensive. But around 1930, researchers at the Shirley Institute had a breakthrough with a new antifungal product known as salicylanolide. Because that was a mouthful, they called it Shirlan for their institute. For over a decade, Shirlan was the single best way to prevent cotton products from deteriorating over time in warm, moist environments and to prevent their tendering. And so building on their work in the 1930s, Smith was able to identify a number of species of Aspergillus responsible for this mildew. And so here what you're seeing is the Aspergillus organism inside the fabric of the dhoti. Many of you may know that they're called this because Pier Antonio Micheli thought that under a microscope, the Aspergilli looked a lot like the sort of holy water dispenser that he found in the Catholic Church. So importantly, at roughly the same time, a lot of American mycologists were also studying Aspergillum, and they were reclassifying the Aspergillus species. So Charles Thom and Margaret Church published a big monograph reclassifying the family at around this time, or the genus around this time. So Smith's work took that kind of laboratory mycological research and combined it with a much more economic orientation. And it showed how laboratory mycology could really have a sort of major economic significance. This research was pretty important. People were interested in it, so Ray Strick brought him to the London School of Hygiene and Tropical Medicine to work on industrial mycology full-time. So Smith's book introduced industrial mycology. It would go on to have 6 editions. It was a pretty popular text. But it remains the case that this sort of general area of research only became truly popular because of World War II. As Smith explained toward the end of the conflict, quote, "Before the war, much of the loss in tropical countries caused by molds was taken for granted. And moreover, there was no coordinating body, like the Ministry of Supply, to initiate research which would benefit many different industries. There simply had not been enough modern military equipment in a tropical place like New Guinea to justify research at the necessary scale." A similar thing is true, many of you probably know, for penicillin. The antibiotic activity of penicillin, which is produced from penicillium molds, was known for decades before World War II, but it was only produced at industrial scales because the war added sort of millions of dollars into finding ways to produce penicillin much faster. So World War II is often thought of generally as the physicists' war, and people think of this fellow here, Oppenheimer. But I think that we can also think about World War II as the mycologists' war, because without mycologists, the war would have gone dramatically differently. In retrospect, it's a little surprising that it took this kind of large-scale international conflict to get people interested in the question of tropical deterioration. After all, the bananas that arrived from Central America to places like New Orleans, which is shown here in the 1920s, were gathered in tropical climates by workers whose health was a major economic and social concern at that time. Public health researcher Alfred Reed, for instance, explained in an overview of the field of tropical medicine that attention to tropical medicine was one key indication that everywhere commerce, business, and government are recognizing that more and more of mankind must live in close relationship with the tropics. So there was this idea that a lot of Western folks were moving to the tropics and that it needed to be made safe for them. One example from the time, this is a 1914 newspaper headline of a speech by Army Surgeon General William Gorgas, who said that science had so advanced in the last decade, it is now safe for any white man to make his home in the tropics. So this was a time, but as you can tell, the focus here was really on making white people safe from tropical diseases, not so much on the technological infrastructures that existed in tropical places. It was instead the mass quantities of material moving during World War II that made this consideration somewhat unavoidable. According to one early estimate, nearly 50% of all items shipped by the British military to Burma were lost in transit or sort of destroyed by molds in transit, which is an astonishing amount of stuff if you think about it. As researchers learned, the majority of then identified molds live really well between 75 and 85 degrees at high levels of humidity, which was the exact conditions that were found throughout this region. So this was kind of mold heaven, and it wreaked havoc on a lot of their stuff. In the early 1940s, scientific collaboration began between Australia, England, and the United States, which sort of pooled findings together to figure out how could we protect all of our stuff from destruction by mold and humidity. On the American side, the research organization was partly led by this man, Selman Waksman, who is better known for coining the term antibiotic and leading the discovery of streptomycin. But Waksman was important in leading the kind of American side of the tropical deterioration fight. Over the course of the Allied work, the Australians found, for instance, that US packed things were a lot better than British packed things. I'm not totally sure why, but Americans were, I guess, just better at that. And this was actually one of the major revelations that pushed Australia away from a traditional relationship with England and toward a relationship with the United States. So the kind of Australian-American technological relationship really got going at this moment in World War II. Because of the urgency of this concern, research initially took place in metropolitan laboratories. So in London, Smith and Raystrick at the School of Hygiene and Tropical Medicine became kind of the semi-formal experts on how to protect things from tropical deterioration. They constructed tropical chambers where temperature and humidity could be kept at artificially elevated levels to facilitate mold growth and to try to kind of test product deterioration. As simulations of a faraway environment, I think that they didn't really understand very well. These experiments are really important as an attempt to kind of domesticate faraway tropical places and recreate them inside of temperate climates, so the same way that we can grow all kinds of wonderful trees here despite the snow in Ithaca. But the question or the problem was this didn't work that well for them. These tropical chambers just didn't produce the right conditions. So as the war pressed onwards, it was also deemed important to establish tropical testing stations throughout the world. So in the early 1940s, Britain founded the West African Tropical Testing Establishment in colonial Nigeria in Port Harcourt, which you'll see. Oh, I lost my little arrow down to kind of the bottom on the coast. Port Harcourt, there we go. Yep, there's the arrow. And at the station, both electrical and textile goods were tested aggressively in sort of similar tropical conditions to see how they would hold up over time, what kinds of products could protect them from deterioration. An exhibit in Australia in July 1945 confirmed just how central packing seemed to be for the war effort. We don't typically think of like waterproof cardboard as an exciting development of World War II, but here it is literally central in this museum exhibit to like what are the technological developments of the period. Tropic-proofed items emerged as a really visible signal that could be shared with the public of the kind of innovations of the Allied military's flexible approach to warfare. There were similar exhibits also in the UK, which kind of showcased these findings to the general public. So tropic packaging became this really essential example of sort of how adaptable the American and British militaries were. By the end of the war, electronics were being hermetically sealed to resist moisture. Binoculars were shipped with silica gel inside to resist molds. Packaging materials were now waterproof and resistant to humidity. So an entire tropical sort of protection regime had come into operation. And these developments were very much a shared project, but if British researchers like Smith and Raystrick had kind of the initial advantage, by the end of the war, it was really American mycologists who were the leaders in the development of a lot of these findings. For instance, the Tropical Deterioration Information Center, which was located at George Washington University, became kind of the centerpiece of collating all of the information that existed about mold management and prevention. Many British researchers found this to be a rather upsetting development because they had been the traditional experts in mycology. Now it was in the United States that sort of fungal knowledge was was best kept. And this was a scientific shifting of the guard that had really important implications for the history of biology in the 20th century. Tropic proofing may not have really won the war for the Allies, but I think it aided in their fight, and it caused some major changes. The first, and I think most important for those who work here, is that it spurred a really large transformation in the field of what we maybe now think of as fungal biology. So in his presidential address to the Mycological Society of America in 1949, Fred Sparrow, who you see here, explained, quote, that the field of mycology has been given a new impetus and drive in the United States in recent years. For many years, research in mycology has been primarily morphological and taxonomic, and it has been fruitful work indeed. But new research, Sparrow continued, was making possible the recent development and expansion, almost by leaps and bounds, of new fields of investigation. And in one of the examples of these sort of new fields that were really important, he talked about new research on Neurospora. Sparrow perceived the emergence of what he called a new mycology, and he argued that the MSA needed to adapt itself to this new biological laboratory style of inquiry. Mycologists were no longer principally taxonomic botanists. They were practically inclined. They worked with the military. They worked with agricultural groups. And increasingly, much of their research was focused in high-tech laboratories. They used things like electron microscopes. And a major cause of this change, Sparrow mentioned in his presentation, was the war, that it had given tons of money to a lot of these researchers and allowed them to develop brand new biological research regimes. It's around this same time, in the mid-1950s, that, oh yeah, they're coming, that Jeffrey Ainsworth started to publish a series of articles on a problem that was facing researchers of his generation. There was too much mycological information for them to keep up with. There's just too much knowledge. In a lecture he gave to graduate students at the University of Wisconsin in 1962, Ainsworth explained, quote, mycological information is increasing exponentially, and the literature of mycology is today published in more languages and scattered through more publications than ever before. Mycologists, in common with other scientists, have the problems of noting, sorting, storing, and retrieving information, problems that are complicated by the fact that in addition to the literature, much mycological information is kept as dead specimens preserved in herbaria and as living specimens conserved in culture collections. So many of you are probably familiar with this idea that there's too much science to keep up with, but the point is that this was already acutely felt in 1950. And in fact, it was felt even earlier than that. So the third group in this figure that I think looks like a kind of avant-garde heavy metal band is Italian mycologist Pier Andrea Siccardo. In the late 1800s, Siccardo began collecting all known species of fungi with the help of a bunch of assistants into a single multi-volume book, which he called the Sylloge Fungorum Omnium Hocusque Cognitorum, the collection of all presently known fungi. He wrote it in Latin because he considered Latin a universal language that everyone could speak, and so it solved the problem of translation. You have Italians, you have Americans, you have Japanese folks. They're all doing mycology, but they can't speak to each other. Well, if they use Latin, that'll solve all of those issues. He sent letters and postcards, like this one below, to researchers all around the world to exchange samples, turning the Botanic Garden in Padua into a kind of center place for the collection of specimens. And this sort of mail exchange was uniquely possible at this moment in time because the Universal Postal Union had just gotten started during this period. So in the past, if you sent a postcard, you had to worry about the local cost, exchanging your money, whether you'd be charged extra at transit. The Universal Postal Union meant that Siccardo could send a letter from Padua, it would get to America, and everyone is paying roughly the same price. So the exchange of exicata, things like that, was uniquely possible in this moment. Siccardo got started in the early 1880s, and he thought that he could list every species of fungus within 8 years. Unfortunately, it turned out that it was a really difficult project, and he was still working on it, and the 25th volume came out in 1931. So for almost 50 years, most of his life, Siccardo was trying to list all of the species. And even more recently, we know that the arrival of internet-enabled mycology in the 1990s did not cause the information problem to disappear, but rather to mutate. So in a 1998 paper, Kathy Hodge and Tom Volk predicted that the World Wide Web would enable researchers across the planet to search large databases of species and access specimen identification keys that were formerly only available to those with privileges at specialty libraries. So there's kind of a democratizing vision of mycological research. And I'll say that they were right about this. that you can do all of these things now, right? But scholars at the time also worried that this internet-enabled mycology was creating new problems for the working scientist. After all, if a species was first published online and the website went away, how could you ensure that that information would be saved? How could you believe that something was a species if it wasn't published in a book? I think today we're now very aware that when databases disappear, a lot of knowledge can go with them. And even more close to the present, with the flood of new possible species identified with advanced sequencing techniques, yet without obvious morphological characteristics, there are new questions about what it means to name or identify an organism in the first place. So what I'm hoping to suggest here is that I think history can help orient us to some of these ongoing conversations about arranging and controlling mycological knowledge. Subsequent generations have felt flooded by overwhelming quantities of information for over 100 years, each time made possible by new technological developments of their ages. Each of these generations developed new tools and new ways of coping with this changing world of information. But it was really the war that kind of got a lot of this started and sort of made the massive expansion of mycology possible. So that's the kind of scientific transformation. But another major sort of result of a lot of this wartime research into tropical deterioration was in how this affected the world of industrial products and their movement around the globe. The US Tropical Deterioration Information Center, which was that bibliography group I mentioned, rebranded in 1945 as the Prevention of Deterioration Center. Its bibliographers carefully collected all kinds of information about deterioration problems. But the name change, I think, signaled that they were expanding from a focus on tropical questions to deterioration at the kind of broadest possible level. In 1954, they published a general guide, The Deterioration of Materials, which its cover celebrated as, quote, the first book ever published to cover all aspects of deterioration prevention, which is a very exciting claim, you can imagine. And the center, which continued operations until 1964, continued to receive extensive support from all the branches of the American military. And part of the reason is that the American military did not give up on the importance of tropical deterioration after World War II. Instead, the US kept access to tropical testing facilities in places like Panama, and Britain maintained access to them until they were kicked out of Nigeria when it became an independent country in 1958. Well, they closed in 1958. Independence came later. The US military has fought to maintain these, and part of the reason is that studies in the middle of the 20th century predicted that all future conflicts were likely to take place in tropical environments. So the American military had to continuously test all of its goods in tropical places. This kind of came to a head in 1977 when the Carter-Torrijos Treaty required the US to leave Panama, potentially lose access to this tropical testing facility. That didn't quite happen, and the US actually maintains a lot of tropical testing all across the globe. So what I'm hoping to kind of suggest also is that this early sort of mycological research focus into tropical deterioration was not just important for scientists, it also underwrote an expansion of the American military all across the planet in a vision of sort of American military power that could be projected anywhere at any time, because American guns could be safe and protected, whether they're here, whether they're in Guam, or whether they're somewhere else. So it didn't just change science, it really changed how the American military imagined its readiness on a global scale. And it also really affected visions of post-war international trade. So after the war, you have a lot of companies who emerge and start to talk about the exciting new ability for American corporations to expand their business across the planet. In 1944, John Glenn of the Pan American Trust Company noted that American business could take advantage of post-war world trade, expanding into new markets. He wrote that the restoration of world economy after the war will offer a tremendous opportunity to American production. And importantly, he stressed that this opportunity would rely on willingness to take advantage of all of these wartime developments in packaging and shipping. The new techniques developed during the war were perceived as sort of essential elements of the expansion of American corporate sort of development. As Scientific American explained in 1945, commercial shippers may not be working in quite the same areas, but they could use these new tropical shipping and prevention discoveries in order to sell their goods in all kinds of places. You could build a motorcycle in the United States, you could get it to the Philippines, and it would be in fine working condition when it arrived. So it enabled this vision of a truly global kind of capitalist enterprise. There were a vast array of research programs into various sort of modes of fungus prevention and tropic proofing. Paper and paperboard got studied extensively, and I'll just note that this study, for instance, emphasized that trade with tropical areas was increasing. So the reason for doing a lot of this research was this expansion in tropical trade. There are countless examples of this research. I won't list all of them, but much of it concerns this idea of adapting wartime discoveries to the new peaceful post-war environment. And even at the height of optimism about peaceful uses of radioactivity, there were suggestions by some people that you could zap underground cables with high levels of radiation to keep fungi from destroying them. So a lot of ways to fungus-proof the New World Order. There's one more important development that I think came from a lot of this, and it concerns a new material that was popularized during this period because of its fungal resistance. So PVC, or polyvinyl chloride, was discovered in 1872 by chemist Eugen Bolman, but it only received widespread application in the 1930s and 1940s after chemist Waldo Seaman at the Goodrich Company boiled some waste PVC and turned it into this flexible plastic. Virtually immune to fungal deterioration, PVC was used widely after the war for things like vinyl records, pipes, and even some mini golf hazards. In 1966, the Goodrich Company produced 260 million pounds of PVC a year, and today the most recent estimate I could find is that nearly 6 billion pounds of PVC is produced annually in the United States, so massive amounts of this stuff. And the problem, as you can probably predict or already know, is that PVC is extremely damaging to the environment. Both its production and its life cycle release harmful chemicals that build up in water, air, food chains, et cetera, and cause a variety of human health problems. So I think from the present sort of vantage point, we can tell a very different story about fungal deterioration. This was not just a development about kind of miraculously overcoming the environment and building all these wonderful fungus-proof things, but of creating a host of new materials and processes that didn't just resist the environment, but actually potentially destroyed the environment. So it was a multifaceted transformation. And today, with all the stories about how fungi might save us, we're experiencing a kind of ironic inversion of a lot of this history. As unrecyclable plastics give way to sustainable alternatives, now you have the idea that we can actually build all of our shipping boxes out of fungi themselves. So you don't need to protect boxes from fungi. You can build boxes out of them. Industrial mycology is thus kind of reemerging to neutralize a problem partly of its own making. Industrial mycology was thus an essential component in the system of production and exchange that expanded around the world after World War II. The universe of fast-moving commodities in waterproof boxes with those little desiccating silica gel packets that you never totally know what to do with, shielded by plastic wrap, all of this got started after World War II, and it was made possible by major advances in mycology. This system, as we know, is also a rather destructive one, and by studying how sort of this knowledge changed and transformed, how it was lost, how it developed, I'm hoping we can better approach the present and the ecological problems that we deal with today. Now, I'll end by returning to a more basic question for you all, which is what it means to study a fungus and why anyone would want to do that in the first place. So in 2011, the late Cornell mycologist Dick Korff addressed the Congress of Latin American Mycology. At the time, Korff worried that granting agencies were now aggressively dictating what kinds of research people could do. The traditional ivory tower, he worried, was disappearing. It was being destroyed by commercial forces, which I think we're familiar with. But Korff insisted that I do not find this to be a doomsday picture, but rather a candid view of our future in which we can hope, by changing our focus, to pursue the holy grail of saving whatever we can of our natural diversity. I see this as a moral duty, and I'm convinced that we have the ability to change our focus to one of serving society. So in a complicated moment like the one we find ourselves in today, perhaps we can take some solace in knowing that others have faced down a lot of the problems about funding, political involvement with research, and we can embrace the work of saving what we can. I'll stop there. Thanks so much, everyone, for listening. Yeah, and yeah.
You didn't mention it, but I'm curious if part of the research for your book includes like culinary mycology.
Yeah, can you say more about what?
Just like I'm thinking of like culinary, like production for edible mushrooms, but also I guess like foraging is a big thing.
Yeah, absolutely. So yeah, I almost talked about this today, in fact. So I'm sorry, I feel like I missed an opportunity. One interesting part about it, there's a major transformation in how mushrooms are grown and produced for agriculture, starting in the late 19th century, continuing into the early 20th century. So in the early 1800s, you have these like interesting French guys who start going into the catacombs of Paris and growing mushrooms underground, which they realize is the perfect place to do it because it's kind of artificially temperature controlled, it's protected from rain, et cetera, et cetera. And this idea of using caves to grow mushrooms becomes super, super popular at the end of the century. You have Americans try to do it, for instance, in Mammoth Cave, the national park. This kind of fails because it turns out there isn't a big market in Kentucky for mushrooms. But you get a lot of these projects to kind of turn caves and abandoned tunnels, et cetera, into mushroom production facilities. But the Americans make really major advances in pure culturing and then growing mushrooms in sort of controlled, like outside greenhouses and stuff. So that's how you get to the fact that Kennett Square, for instance, is now one of the world mushroom production meccas. And a lot of this has to do with sort of research in a little bit of an earlier time period, but that takes some of these pure culture techniques and then applies them to agricultural production. So it's part of the project, and I am interested in kind of tracing this further. Also, there's a kind of connected question of like the production of soy sauce and a lot of these culinary products that require kind of industrial mycological work. So all of this will hopefully be in the book, but thank you for the question. Yeah.
Yeah, thanks for your talk. It was really great. You mentioned that it's kind of surprising that it took so long for industrial mycology to emerge as an area of study, given how long for that trade in the tropics had been going on with perishable things. I wonder if you could say a bit more about why you think it took that. Why do you think it didn't emerge in previous centuries?
Yeah, well, I think that part of the easy answer, I suppose, is that there was not enough stuff yet in tropical places, and it wasn't deteriorating at a fast enough rate. And I mean, as I kind of said here, World War II is a really wonderful moment well, no, it's a bad moment, but from a kind of industrial and scientific standpoint, it's a really interesting moment because you have so much money being invested with very little sort of concern about, like wasted funding. It's like if there's an urgent problem, it's worth working on. And so you get massive investments in the problem of tropical deterioration, which are just unthinkable in any earlier decade. There's nobody had enough money for that to make sense. But if our soldiers are literally getting lost in the jungle because their radio sets are being eaten away by molds and they can't even talk to each other, they can't see through their guns. I mean, that's a life and death problem. And so the US military invests a massive amount of money. And of course, the same is sort of true with the Manhattan Project, that you have these massive fundamental advances in physics that are possible because an enormous amount of money is invested into these questions right during that time period. And if I had an audience of politicians here, I would argue that this kind of massive expenditure has all kinds of sort of fundamental and basic benefits, right? It's just that kind of broad project dream of sort of spending tens or hundreds of millions of dollars at a time to solve these problems kind of dries up afterwards, but it doesn't exist in kind of the earlier period. Yeah.
I had a question about permits. When you're talking about the exchange of material and collecting all the different fungi, I imagine that maybe it's gotten more like permitting and exchange more restricted over time, but is that true, or does that play out where there's relaxes in regulation and then stricter regulation, and does that influence the process?
So this is for like collecting samples and sort of shipping them around the world.
Yeah, so like there's negative impacts you could have outbreaks in other areas, things like that.
Yeah, well, disappointingly, early in the 20th century, there are very few restrictions about what you can take from a place and ship elsewhere. And a lot of the sort of charm or humor of looking at like Sicardo's correspondence is that the biggest problem is just that if someone shipped something from North America, so like J.B. Ellis would send him stuff, and it would just get lost at, all the time on boats, and it would get stuck at the post office for months because the post office didn't know what was in it, and it was, the real concern was that it was a weapon, or something was being kind of illegally moved across international. So there's very little concern about that early on. That said, there's also not that much interest at the time in studying the sort of the funga of non-Western places. So the really intense focus is on European, North American, to some extent, sort of Japanese species. There's not a lot of attention to Central American, South American, African populations. So even though there are very few restrictions, the kind of ideological focus meant that a huge amount of sort of possible questions weren't really asked at this time in terms of species that could have been studied, but just there wasn't enough attention to them. It definitely changes, of course, as you get into the later 20th century when things become a lot harder to just kind of pick up and ship around. But yeah, there weren't a lot of restrictions early on. And Curtis Gates Lloyd, who's a wonderful sort of mycological history figure that some may know about, lives in Cincinnati, and he creates this journal called Mycological Notes. And he says that if you ship him a mushroom from anywhere in the world, he will identify it and he'll send you a free copy of Mycological Notes. And he has a bunch of money that he's made through pharmaceutical research, so he's able to do this in a way that most other people can't. And the amazing thing about Lloyd is that he is getting things shipped to him from just everywhere across the planet at a kind of breathtaking scale, and develops this unbelievable dried specimens collection, in part because there are almost no restrictions. And he's got all these guys like who are just bored colonial administrators in like Angola or Singapore, and they're like, I didn't have much going on, so I went out the other day, I found this mushroom, what is it? Please let me know in a couple months. So you get this kind of spectacular international trade at that time, but it's slow to communicate. There's a lot that's lost in transit because dried specimens don't hold up very well when they're received. So there are different kinds of problems at that time.
Any other questions from our audience today? Well, I hope you'll join me. Oh, go ahead.
Oh, this is a little random, but so early on you showed the magazine being like completely destroyed by mold.
Mm-hmm.
So I imagine that would be made out of metal, but molds can't eat metal. And so I'm wondering how did it get that destroyed that quickly? Was it just like acid production or?
Yeah, I mean, so there are a couple problems that they deal with during this time. And one thing that I suppose I should have talked about a little bit more is that at first, the major concern is only about mold action. So it's initially a kind of purely mycological concern. It's like, how do we stop the molds from getting in? Because they do like cloud gun sites from the inside, which people can't figure out. But it does become clear that after a while, molds aren't the only problem, that the other problem is just massive constant humidity. And so you have things that are just in very wet environments where metal is corroding very, very quickly over extended periods. And it's kind of the combined effect of kind of moisture corrosion and kind of fungal activity that causes this like massive destruction. So boxes get destroyed by fungi, but then metals get sort of ruined by all kinds of other like rust and other processes.
All right, well, will you join me in thanking Brad for?
Thank you all so much.
This has been a production of Cornell University, on the web at cornell.edu.